Hello student, myself Divya Parmar. Welcome you all to the online session of Principle of Electronic Communication, in which we are learning about amplitude modulation. Let's start with the contents. First, amplitude modulation, mathematical expression of amplitude modulated wave, modulation index. So, let's start with the amplitude modulation. A continuous wave goes on continuously without any intervals, and it is the baseband message signal which contains the information. This wave has to be modulated. According to the standard definition, the amplitude of the carrier signal varies in accordance with the instantaneous amplitude of the modulating signal, which means the amplitude of the carrier signal containing no information varies as per the amplitude of the signal containing information at each instant. The first figure shows the modulating wave, which is the message signal. The next one is the carrier wave, which is the high frequency signal and contains no information, while the last one is the resultant modulated wave, that is amplitude modulated wave. It can be observed that positive and negative peaks of the carrier wave are interconnected with an imaginary lines. This lines helps recreating the exact shape of the modulating signal. This imaginary lines of the carrier wave is called as an envelope. It is the same as that of the message signal. Now the next is a mathematical expression of an AM wave. Following are the mathematical expression for this wave. Time domain representation of the AM wave. Let the modulating signal can be m of t, that is equals to am into cos 2 pi fm of t, and the carrier signal is c of t, that is equals to ac into cos 2 pi fc of t, where am and ac are the amplitude of the modulating signal and the carrier signal respectively. FM and FC are the frequency of modulating signal and the carrier signal respectively. Then the equation of an amplitude wave is S of t, that is equals to AC plus AM into cos 2 pi FM of t into cos 2 pi FC of t. The next is modulation index. A carrier wave, after being modulated, if the modulation level is calculated, then such a term is called as a modulation index or a modulation depth. It states the level of modulation that a carrier wave undergoes. Rearrange the equation 1 as shown in the figure. S of t, that is equals to AC into 1 plus am by ac into cos 2 pi fm of t into cos 2 pi fc of t, that is equals to S of t is ac into 1 plus mu cos 2 pi fm of t into cos 2 pi fc of t, that is equation number 2, where mu is the modulation index and it is equals to the ratio of am and ac. Mathematically, we can write it as a mu, that is equals to am by ac. That is the equation number 3. Hence, we can calculate the values of modulation index by using the above formula. When the amplitude of the message and the carrier signal are known, now let us derive one more equation for the modulation index by considering the equation 1. We can use this formula for calculating the modulation index values when the maximum and the minimum amplitude of the modulated wave are known. Let A maximum and A minimum be the maximum and minimum amplitude of the modulated wave. We will get the maximum amplitude of the modulated wave when cos 2 pi fm of t, that is equals to 1. So the equation is A maximum, that is equals to am plus ac. That is our equation number 4. We will get the minimum amplitude of the modulated wave when the cos 2 pi fm of t, that is equals to -1. So the equation will be A minimum that equals to AC minus AM. That is our equation number 5. Add the equation 4 and 5. So we get A maximum plus A minimum that is equals to AC plus AM plus AC minus AM. So we get 2AC. So the equation is AC that is equals to A maximum plus A minimum by 2. That is our equation number 6. Subtract the equation number 5 from the equation number 4. So we will get A maximum minus A minimum that is equals to AC plus AM minus AC minus AM. So we will get from the equation that is 2AM. Now AM that is equals to A maximum minus A minimum by 2. This is our equation number 7. The ratio of equation 7 and the 6 we can write as follows. AM by AC that is equals to A maximum minus A minimum by 2 into A maximum plus A minimum by 2. So the mu that is equals to A maximum minus A minimum upon A maximum plus A minimum. That is our equation number 8. Therefore, equation 3 and 8 are the two formulas of modulation index. The modulation index or the modulation depth is often denoted in percentage called as a percentage modulation. We will get the percentage of modulation just by multiplying the modulation index values with 100. For a perfect modulation, the value of modulation index should be 1, which implies the percentage of modulation should be 100%. For instance, if the value is less than 1, we can take an example like the modulation index that is equals to 0.5, then the modulated output would look like the following figure. It is called as under modulation. Such a wave is called as under modulated wave. If the value of modulation index is greater than 1, so take example like it is like 1.5, or so the AM wave will be an over modulated wave. It would look like as shown in the diagram. As the value of modulation index increases, the carrier experiences a 180-degree phase shift reversal, which causes the additional sidebands and hence the wave get distorted. Such a overmodulated wave causes interference which cannot be eliminated. Assignment questions regarding to this video are: first, what is amplitude modulation? Derive the mathematical expression of amplitude modulated wave. Define under modulation and over modulation of AM wave. See you in the next session of Principle of Electronic Communication. Thank you.
If you like this video, please subscribe and like our YouTube channel LJPEC, and don't forget to click on the bell icon to get latest video update fast.